Hello folks! In this video we are going to solve a resistive linear circuit, and the idea here is to find the value of E3 that makes the current along the central branch equal to 0, and for this we are going to consider that E2 and E1 are equal to 20 volts and the resistances in the circuit equal to 20 ohms. This is the data that the exercise gave us, and it is enough to calculate what the exercise wants us to calculate. Let's do it. Let's go to the solution. For all t, I1 plus I2 plus I3 is equal to 0. Okay? The current that entered this node must be equal to the current that leave the node. There is no current leaving the node, only currents entering in the node. Then the sum must be equal to 0. Alright? But who is I1? I1 is E1 minus E0 divided by R. The exercise gave E1 but did not give E0. E0 is just a reference voltage that I used here that would allow us calculate what we want. And who is I2? I2 is E2 minus E0 divided by R. And who is I3? I3 we wish to be 0. Then we're going to use that I3 is 0 and the sum has to be equal to 0. Alright. Let's substitute the values. 20 volts minus E0 divided by 20 ohms plus the same here. 20 volts minus E0 divided by 20 ohms has to be equal to 0. Here we can cut this with this because the denominator is 0, okay? Then we can simplify the problem in this fashion. And here we have that 20 volts minus E0 plus 20 volts minus E0 is equal to 0. Therefore, we find that E0 is equal to 20 volts. If the current I3 has to be equal to 0, then there is no voltage drop here. No voltage drop here on top of this resistor here. Therefore, we can conclude that E3 is actually equal to E0. Alright, my friends? Does it make sense to you? I hope so. Alright, my friends, this is the exercise that I wanted to solve with you. I am a teacher. If you want to book a lesson with me, use my WhatsApp number, guys. Goodbye!